Welcome to Goldwyn Education. I'm Manawar Masood. Dive into a world of learning and discovery with us. Subscribe now for insightful tutorials and engaging lectures. Let's learn together.
Pressure indicating device. Definition. A pressure indicating device, commonly known as a pressure gauge, measures and displays the pressure of fluids within systems. Utilized across industries like manufacturing and aerospace, it ensures operational safety and efficiency. The gauge typically features an analog or digital display, showcasing pressure levels in units like psi or bar. Variants include Borden tube gauges, using a curved tube to measure pressure, and digital sensors offering precise readouts and advanced features like data logging.
Today we discuss 1. Function of pressure indicating devices. 2. What makes these devices tick? How do they manage to keep their accuracy intact? 3. Proper result came from proper calibration.
4 proper calibration depens on proper calibration guidalina.
Ever wondered how engineers and scientists measure pressure in different systems? Well, let me introduce you to the unsung heroes of the engineering world: pressure indicating devices. These are the silent sentinels that keep a watchful eye on our systems, measuring and displaying pressure with an impressive degree of precision and reliability. In the realm of pressure indicating devices, we find a diverse cast of instruments, from pressure gauges that monitor the pressure within hydraulic systems, to manometers that measure gas pressure, to sensors and transmitters that help pilots keep an eye on the air pressure in an aircraft cockpit. Each one of these devices plays a vital role, ensuring that our systems operate safely and efficiently. You might be thinking, okay, but how do these devices actually work? Well, in essence, a pressure indicating device is a tool designed to measure and display the pressure of a substance within a system. They provide us with accurate measurements, present them in formats that we can easily understand, and allow for real-time monitoring to ensure safe operation. But it doesn't stop there. For these devices to provide us with reliable measurements, they need to be calibrated periodically. Calibration is the process of adjusting a device to maintain its accuracy over time. It's a bit like tuning a musical instrument to make sure it's always playing the right notes. Following calibration guidelines is crucial for consistency and compliance. These guidelines provide a systematic and effective roadmap for the calibration process, covering everything from selecting reference standards to evaluating uncertainty. So the next time you come across a pressure indicating device, take a moment to appreciate the precision, the function, and the care that goes into ensuring it delivers accurate results every time. Because when it comes to pressure, accuracy really does matter. Now let's dive deeper into how these devices function and why calibration is crucial. So, how do these devices manage to measure pressure with such precision? Well, it all begins with the fundamental function of pressure indicating devices. These tools are designed to measure and display the pressure of a substance within a system. Let's say you're working with a hydraulic system. These devices will tell you exactly what the pressure is inside that system. It's like having a tiny, highly specialized scientist in your machinery, constantly observing and recording vital data. But it's not just about measuring pressure. These devices also display it in a format that's easy to understand. That could be a dial with a needle pointing to a number, a digital readout, or even a color-coded system. The goal is to make the pressure inside a system visible and comprehensible, even to a casual observer. Now, let's talk about real-time monitoring. This is where pressure indicating devices really shine. These devices don't just take a single measurement and call it a day. They are constantly monitoring the pressure, providing up-to-the-minute data. This ongoing surveillance is a crucial part of ensuring safety in industries like aviation and manufacturing, where a sudden change in pressure could be a sign of a serious problem. Imagine you're a pilot flying through the clouds. Your aircraft's pressure indicating devices are your eyes and ears, telling you what's happening inside the engine and the cabin. If the pressure drops suddenly, you'll know about it immediately, and you'll be able to take action to keep the aircraft safe. But here's the thing, the accuracy of these devices is not a given. It's not enough to simply install them and hope for the best. These devices need to be kept in tip-top shape, and that's where calibration comes in. Calibration is the process of checking the accuracy of a device and adjusting it if necessary. It's a bit like taking your car in for a tune-up. Just as you wouldn't trust a car that hasn't been serviced in years, you wouldn't want to rely on a pressure indicating device that hasn't been calibrated. But the accuracy of these devices is not a given. It's maintained through a process called calibration. What exactly is calibration, and why is it so important? Well, let's dive in. Calibration is a process that ensures pressure indicating devices maintain their accuracy over time. It's like a tune-up for your car, but for these precision instruments, providing reliable and accurate measurements when we need them most. Imagine you're a pilot, relying on your cockpit's pressure gauges to ensure safe flight. Or perhaps you're an engineer, monitoring the pressure within a hydraulic system. In both scenarios, the readings from these devices are crucial. But what if they're off even by the slightest degree? The consequences can range from minor inefficiencies to catastrophic failures. That's where calibration comes in. Calibration is a meticulous process that involves preparation, adjustment, and verification. First, the device is prepared, ensuring it's clean, stable, and ready for calibration. Then it's adjusted to match a known reference standard, a device that's been calibrated to an extremely high degree of accuracy. Finally, the device is verified, comparing its readings against the reference standard to ensure they align. But calibration doesn't stop at the device level. It's also about maintaining consistency and compliance across the board. That's why following calibration guidelines is so crucial. These guidelines serve as a roadmap for performing the calibration process systematically and effectively. They cover every detail, from selecting the right reference standards to evaluating the uncertainty in measurements. Following these guidelines ensures that, no matter where the device is used, it meets the highest standards of accuracy and reliability. So when you see a technician meticulously adjusting a pressure gauge or diligently referencing a calibration guideline, know that they're not just turning screws and ticking boxes. They're upholding the integrity of our systems, ensuring that everything runs smoothly, safely, and efficiently. Now that we know how calibration works, let's understand what these guidelines entail. Because in the world of pressure indication, accuracy isn't just important, it's absolutely critical. Every single reading matters, every adjustment counts, and every calibration makes a difference. So the next time you come across a pressure indicating device, remember the precision, the care, and the importance of calibration that goes into ensuring its accuracy. Calibration guidelines may sound complex, but they're essentially a set of instructions. They're the roadmap that guides engineers and technicians to ensure that pressure indicating devices are performing optimally and accurately. First up, what do these guidelines entail? Well, they cover a range of elements, starting with the selection of reference standards. These standards are the benchmark against which the device under test is compared. They have to be known, accepted, and more accurate than the device being calibrated. Next, the guidelines help technicians prepare the device for calibration. This could involve cleaning, zeroing, or adjusting the device to ensure it's ready for the process. Then comes the actual calibration process. Here, the device is subjected to a series of tests, comparing its readings to those of the reference standard. Any deviations are noted and adjustments are made to align the device's readings with the reference standard. After the adjustments, the device is retested to verify the accuracy of the calibration. This process is repeated until the device's readings match the reference standard within an acceptable range, but the process doesn't stop there. The guidelines also cover post-calibration activities like documenting the results and maintaining detailed records. These records are vital for tracking the device's performance over time and ensuring compliance with regulatory standards. Another key element of calibration guidelines is the evaluation of uncertainty. This is an estimate of the possible deviation in the device's readings. By understanding and managing this uncertainty, we can ensure the device's readings are as accurate as possible. But why are these guidelines so important? Simply put, they ensure that our pressure indicating devices meet the highest standards of accuracy and reliability. By following these guidelines, we can trust our devices to provide accurate readings, whether we're monitoring the pressure in an aircraft cockpit or measuring the pressure within a hydraulic system. With these guidelines, pressure indicating devices can deliver accurate results every time. So let's appreciate the care, precision, and technical expertise that goes into calibrating these silent sentinels of our systems. So the next time you see a pressure indicating device, remember the precision, function, and care that goes into it. These devices are more than just passive instruments on a dashboard or a control panel. They are the vigilant guardians of our systems, measuring and displaying pressure with pinpoint accuracy and unwavering reliability. Each type of pressure indicating device, be it a gauge, a manometer, a sensor, or a transmitter, serves a unique purpose. They measure everything from the pressure within a hydraulic system to the atmospheric pressure in an aircraft cockpit. These devices are the unsung heroes of our industries, silently ensuring the smooth and safe operation of our systems. But the accuracy of these devices doesn't happen by chance. It's the result of careful calibration, a meticulous process that ensures these devices maintain their precision over time. Calibration is a multi-step process, including preparation, adjustment, and verification, that ensures the readings we get are as accurate as they can be. And the key to successful calibration? Following calibration guidelines to the letter. These guidelines are a roadmap to accuracy, covering everything from selecting reference standards to evaluating uncertainty. Adherence to these guidelines ensures that our pressure indicating devices meet the highest standards of reliability. Our journey today has taken us through the world of pressure indicating devices, unveiling the intricate processes behind their functions and the critical role they play in our everyday lives. From the simple act of inflating a car tire to the complex operations of an industrial plant, these devices are instrumental in ensuring safety and efficiency. So, let's not take these devices for granted. Let's appreciate the precision, the function, and the meticulous care that goes into each one of them. Because, as we've learned today, when it comes to pressure, accuracy matters. It's not just about numbers on a dial, it's about the safety and efficiency of our world. Thank you for joining us on this journey through the world of pressure indicating devices. Until next time, stay curious and keep innovating.